This is a video for OCR, Pure Core Mathematics, Calculus 1 Improper Integrals, 1.1 Integrals with Infinite Limits, Convergent. What do we mean by an improper integral? Well, an improper integral is one where we're attempting to evaluate an integral and there may be a problem. Specifically, at least one of the limits is infinite. So for instance, we might be trying to integrate x dx between 2 and infinity. And this upper limit of infinity may present a problem. Alternatively, the function might approach infinity at some point in the interval. And again, as an example, think about this integral between -1 and 2 of 1 over x dx. There's an issue here as x tends to 0 because 1 over x tends to infinity. And so that means that we've got a problem somewhere in this region at x equals 0. So let's have a look at this function. This is 1 over x squared, and we're integrating it between 2 and infinity. So there's my problem limit. Now let's have a look at the function itself. As x tends to infinity, the function decreases. And indeed we know it tends to a limit of 0. What about this area? Does the area tend to a limit, or does it head off towards infinity? To look at that, we're going to look at the limits in detail. So here's my integral. I'm going to rewrite this as the integral between 2 and a of 1 over x squared dx, and I've replaced the upper limit with a variable a, and then I'm going to see what happens after I've done the integration as I allow a to tend to infinity. Well, integrating 1 over x squared, I get -1 over x. And that's going to be evaluated between 2 and a, and I'm interested in what happens as a tends to infinity. Well, let's plug in those limits. I'm going to get -1 over a from the upper limit and plus 1 over 2 from the lower. And again, let's see what happens as a tends to infinity. Well, now we can look at what happens. So as a tends to infinity, 1 over a tends to 0. So this bit of our result is going to disappear, leaving me with just a final result of a half. So this integral ends up limited of a half. There's that working tidied up. So here we've done the replacement of the upper problem limit. We've allowed that to tend to infinity, and down here, once we've completed the integral and stuck the limits in, we then look at what happens as a tends to infinity, and therefore we end up with our result of a half. So remember, this is a convergent integral because it actually has a limit. A separate video will look at divergent integrals. So in summary, replace the problem limit with a variable and then allow that variable to tend to your problem limit and see what happens. The next video in this sequence is 1.2 Integrals with Infinite Limits, Divergent.